September 26, 1940. Southampton, 11:17 p.m. The air raid sirens had been wailing for 17 minutes when the first incendiary bombs struck the Supermarine aviation works at Woolston. Within seconds, the sprawling factory complex that produced Britain's most vital weapon, the Supermarine Spitfire, erupted into towering columns of flame that could be seen from Portsmouth, 12 miles away. Inside, night shift workers scrambled through smoke-choked corridors as the building's wooden roof beams began to collapse. Jigs, tools, half-assembled fuselages, everything that made a Spitfire possible, was being consumed by fire. By dawn, when the flames finally subsided, 70% of the factory lay in ruins. 42 workers were dead, and Britain's ability to defend itself from Nazi invasion hung by a thread thinner than a Spitfire's wing. The German High Command believed they had delivered a knockout blow. They had calculated that, without Supermarine's main production facility, Fighter Command would be starved of replacements within 6 weeks. The mathematics were brutally simple. RAF pilots were shooting down German bombers, but they were also dying. Spitfires were being destroyed faster than they could be replaced. And now, the primary source of new aircraft had been reduced to smoking rubble. In Berlin, Luftwaffe intelligence officers updated their projections. Britain's fighter strength would collapse by mid-November. The invasion could proceed. But they had miscalculated. They had not accounted for a 61-year-old Canadian newspaper baron with a volcanic temper, an iron will, and absolutely no respect for bureaucratic procedure. They had not accounted for Lord Beaverbrook, and they certainly had not accounted for what was about to happen across hundreds of small towns, villages, and workshops throughout southern England. What followed would become one of the most remarkable industrial achievements of the entire war. A transformation so complete, so audacious, that it would rewrite the rules of wartime production and save Britain from defeat. The morning after the Southampton raid, Lord Beaverbrook, Churchill's newly appointed Minister of Aircraft Production, stood in the still smoldering ruins of the Supermarine factory. Max Aitken, as he was born, had built a fortune in Canada through sheer force of personality before becoming one of Britain's most powerful press barons. Churchill had given him one job in May 1940. Produce more fighters. Everything else was secondary. Beaverbrook surveyed the destruction with characteristic bluntness. The factory manager, a man named Trevor Westbrook, stood beside him, his face gray with exhaustion and despair. Westbrook began explaining the timeline for rebuilding. 6 months, perhaps 9, before full production could resume. Temporary measures might produce a trickle of aircraft, but the sophisticated jigs and tools required for Spitfire production had been destroyed. The specialized workforce was scattered. Some were dead. Others had lost their homes in the same raid. Beaverbrook cut him off mid-sentence. 6 months. Britain would be speaking German in 6 months. They had 6 weeks, perhaps less. Westbrook tried to explain the impossibility. A Spitfire was not a simple machine. It required precision engineering to tolerances measured in thousandths of an inch. The elliptical wing alone, that beautiful, deadly curve that gave the Spitfire its performance, was a nightmare to manufacture. It required specialized tools, skilled workers, and facilities that no longer existed. Beaverbrook's response would become legendary in British industrial history. Then we will make them somewhere else, everywhere else. In every workshop, garage, and shed in southern England if necessary. We will scatter production so thoroughly that the Germans could bomb Britain flat and never find it all. The men around him exchanged glances. It was madness. It was impossible. It was also their only chance. Within 48 hours, Beaverbrook had assembled a team of engineers, production managers, and logistics experts at his ministry headquarters in London. The plan they developed was unprecedented in industrial history. They would decentralize Spitfire production completely. Instead of one massive factory producing complete aircraft, they would create a network of hundreds of small facilities, each producing individual components. Wings in one location, fuselages in another, tail sections, undercarriages, engine mounts, all manufactured separately and transported to secret assembly points where complete aircraft would be put together. The advantages were obvious. Dispersed production would be nearly impossible for German bombers to destroy completely. Small workshops could be hidden, camouflaged, or quickly relocated. If one facility was hit, the others would continue operating. But the challenges were staggering. Spitfire components had to fit together with extraordinary precision. A wing attachment point misaligned by even a few millimeters could make an aircraft unflyable or, worse, cause it to break apart in flight. How could they maintain such tolerances across hundreds of different workshops, many of which had never built aircraft components before? The answer lay in the jigs. These were precision metal frameworks that held components in exactly the right position during assembly. If they could distribute accurate jigs to each workshop, even relatively unskilled workers could produce parts that would fit together perfectly. The problem was that most of the master jigs had been destroyed at Southampton. So they would have to recreate them, from memory, from damaged examples, from whatever technical drawings had survived, and they would have to do it in days, not months. A 34-year-old engineer named Henry Folland became the unlikely hero of this first crisis. Folland had worked at Supermarine for 8 years and knew the Spitfire's structure intimately. More importantly, he had an eidetic memory for technical specifications. In a commandeered office building in Winchester, Folland worked 18-hour days, recreating technical drawings from memory, checking them against damaged jigs pulled from the Southampton ruins, and coordinating with the handful of senior engineers who had survived the raid. They worked with desperate urgency. Every day without production meant fewer Spitfires to face the Luftwaffe. Fighter command was burning through aircraft at a terrifying rate. Replacement aircraft were arriving from other manufacturers, Hurricanes primarily, but the Spitfire's superior performance at high altitude made it irreplaceable for intercepting German bomber formations. By October 10th, 2 weeks after the raid, Folland's team had recreated enough technical specifications to begin distributing work. Now came the truly audacious part. Beaverbrook's ministry sent out a call to workshops, garages, and small manufacturing facilities across southern England. Could they produce aircraft components? Many of the responses were skeptical. A furniture workshop in Reading, a bus repair depot in Salisbury, a small engineering firm in Trowbridge that normally made agricultural equipment. What did they know about building fighters? But Beaverbrook's representatives were persuasive. They arrived with technical drawings, jigs, raw materials, and a simple message. Britain's survival depended on this. The response was extraordinary. In Reading, a furniture workshop owned by a man named Albert Drew received specifications for producing Spitfire wing ribs. These were the internal structural elements that gave the wing its shape and strength. Drew gathered his craftsmen, skilled woodworkers who had spent their careers making tables and chairs. They studied the drawings. The precision required was far beyond anything they had attempted, but the basic skills were familiar. shaping wood to exact specifications, understanding how structural elements work together, maintaining quality control. Within a week, Drew's workshop was producing wing ribs. The first batch was rejected. The tolerances were not tight enough. The second batch was better. By the third week, they were producing components that passed inspection. Similar transformations were happening across the region. A garage in Newbury began machining engine mounts. A small metalworking shop in Andover started producing undercarriage components. A bicycle factory in Southampton, miraculously undamaged by the same raid that destroyed Supermarine, retooled to manufacture fuselage frames. Each facility received exactly what it needed. Technical drawings, jigs, raw materials, and quality control inspectors who checked every component before it was approved for use. The inspectors were ruthless. A single defective part could kill a pilot. There was no room for error. But the system worked. Slowly at first, then with gathering momentum, components began flowing from dozens, then hundreds of small workshops toward secret assembly points. The assembly points themselves were masterpieces of improvisation and concealment. Beaverbrook's team had identified large buildings across southern England that could be converted into aircraft assembly facilities. A bus depot in Salisbury. A large garage in Trowbridge. A requisitioned country estate near Winchester. Even a partially completed housing development near Reading, where the large ground floor spaces of unfinished buildings provided perfect cover. These locations were kept secret. Workers were transported by bus, often not knowing exactly where they were going until they arrived. The buildings were camouflaged. From the air, they looked like ordinary civilian structures. Inside, they were hives of activity. The assembly process was carefully choreographed. Components arrived by night convoy, transported in covered trucks that moved along back roads to avoid attention. Wings from one location. Fuselages from another. Engines, which were manufactured by Rolls-Royce at separate facilities, arrived under heavy guard. Teams of skilled assemblers, many of them former Supermarine workers who had survived the Southampton raid, put the pieces together. It was painstaking work. Every joint had to be perfect. Every bolt torqued to exact specifications. Every control surface aligned precisely. The first aircraft assembled under the new system was completed on October 28th, just over a month after the Southampton raid. It was transported by truck to a nearby RAF airfield for testing. The test pilot, a squadron leader named Geoffrey Wellham, approached the aircraft with understandable skepticism. This Spitfire had been built in a bus depot from components manufactured in furniture workshops and garages. Would it even fly? Wellham performed his pre-flight checks with extra care. Everything looked correct. The aircraft had been assembled to the same specifications as factory-built Spitfires. But there was only one way to know for certain. He climbed into the cockpit, started the Rolls-Royce Merlin engine, and taxied to the runway. The takeoff was smooth. The aircraft handled beautifully. Wellham put it through a series of increasingly aggressive maneuvers, steep turns, dives, climbs. The Spitfire performed flawlessly. When he landed 40 minutes later, Wellham's report was succinct, as good as any Spitfire he had flown. Perhaps better, since the assemblers had been so meticulous. The dispersed production system worked. But the challenges were far from over. The logistics of coordinating hundreds of small workshops, transporting components, and maintaining quality control across such a dispersed network were staggering. Beaverbrook's solution was characteristically direct. He gave someone absolute authority to make it work. That someone was a 52-year-old logistics expert named William Roots, who ran one of Britain's largest automotive companies. Roots understood mass production, supply chains, and how to coordinate complex manufacturing operations. He also understood that the traditional rules would have to be thrown out. Roots established a command center in a requisitioned hotel in Winchester. From there, he coordinated the entire dispersed production network. A massive wall chart tracked every workshop, every component, every transport convoy. Colored pins showed where bottlenecks were developing. Telephone operators maintained constant contact with facility managers. Motorcycle couriers carried urgent messages when telephone lines were down or insecure. The system operated 24 hours a day. Night shifts were essential because component transport had to happen under cover of darkness. German reconnaissance aircraft regularly photographed southern England, looking for signs of military production. Convoys moving in daylight would be spotted and bombed, so the components moved at night. Trucks with masked headlights, following routes that changed regularly to avoid patterns the Germans might detect. It was dangerous work. Several convoys were caught by German night fighters and strafed. Others were hit during bombing raids on nearby towns, but the flow of components continued. The human stories behind this industrial miracle were remarkable. In a small workshop in Romsey, a 58-year-old machinist named Frank Cooper worked 12-hour shifts producing engine mount brackets. Cooper had lost his son, a hurricane pilot, during the Battle of Britain in August. He approached his work with grim determination. Every bracket he produced was checked and rechecked, every measurement verified. He knew that some pilot, someone's son, would depend on his work. In Salisbury, a 19-year-old woman named Dorothy Marsh worked in the bus depot assembly facility. She had never seen an aircraft up close before the war. Now, she was installing control cables in Spitfire cockpits, threading the thin steel wires through pulleys and attachment points with fingers that had to be both strong and delicate. The work was exhausting. The depot was unheated. In the winter of 1940-41, one of the coldest on record, workers wore fingerless gloves and huddled around small heaters during breaks. But they kept working. Dorothy would later recall the moment when a Spitfire she had helped assemble was wheeled out of the depot for transport to an airfield. She had worked on dozens of aircraft by then, but this one felt different. She had installed every control cable herself, checked every connection twice. Somewhere, a pilot would fly this aircraft into combat. The thought was terrifying and exhilarating in equal measure. Stories like these multiplied across the network. A retired schoolteacher in Winchester who came out of retirement to work as a quality control inspector, checking wing rib dimensions with calipers and an obsessive attention to detail. A 16-year-old apprentice in Andover who learned precision metalworking while producing undercarriage components, developing skills that would serve him for a lifetime. A truck driver who navigated blacked-out roads night after night, transporting fuselage sections from workshops to assembly points, never knowing if German bombers would catch him in the open. The system was not without failures. In November, a batch of defective wing spars was discovered during final assembly. The spars, critical structural elements that ran the length of the wing, had been manufactured with a subtle but dangerous flaw. They would pass initial inspection but could fail under combat stress. Every aircraft using those spars had to be grounded and retrofitted. It was a devastating setback. Dozens of aircraft were pulled from service at a time when every fighter was desperately needed. Roots traced the problem to a small metalworking shop in Basingstoke. The shop had been using a jig that had been slightly damaged during transport. The damage was barely visible, but it was enough to introduce a critical misalignment. The shop manager was mortified. He had been working 18-hour days, pushing his workers to maximum output. He had missed the defect. Roots' response surprised him. Instead of punishment, Roots implemented a new inspection protocol. Every jig would be checked daily. Any damage, no matter how minor, would result in immediate replacement. The shop manager remained in place, but with additional support and oversight. The incident highlighted the system's vulnerability, but also its resilience. The problem had been caught before any aircraft failed in combat. The system had worked, even if imperfectly. And the lessons learned made the entire network stronger. By December 1940, the dispersed production system was operating at full capacity. Monthly Spitfire output had recovered to pre-raid levels. 130 aircraft, but Beaverbrook was not satisfied. He wanted more. He needed more. Fighter command was expanding. New squadrons were being formed. Losses, while lower than during the desperate days of the Battle of Britain, continued. 130 Spitfires per month was not enough. Beaverbrook pushed for increased output. More workshops were recruited. Existing facilities expanded their operations. The logistics network grew more sophisticated. Roots implemented a system of buffer stocks, maintaining small reserves of critical components at multiple locations, so that a disruption at any single workshop would not halt assembly. The results were extraordinary. In January 1941, production reached 180 aircraft. In February, 220. By March, over 260 Spitfires were rolling out of the dispersed assembly facilities. And the quality remained high. RAF pilots reported no difference between aircraft produced under the new system and those built before the war in Supermarine's original factory. In April 1941, monthly production exceeded 300 aircraft for the first time. It was an achievement that seemed impossible just 6 months earlier. Britain was now producing Spitfires faster than Germany could destroy them. The strategic balance had shifted. Fighter command could replace losses, expand squadrons, and even begin building reserves for future operations. The German response was frustrated confusion. Luftwaffe intelligence knew that the Southampton factory had been destroyed. They had the reconnaissance photographs to prove it. Yet Spitfire numbers were not declining. If anything, they were increasing. Where were the aircraft coming from? German bombers struck other known aircraft factories, Castle Bromwich, where Spitfires were also produced, and various Hurricane production facilities. But the attacks had limited effect. British fighter strength continued to grow. The Germans never fully understood what had happened. They were looking for large factories, obvious targets. They never realized that Spitfire production had been scattered across hundreds of small, virtually invisible workshops. The dispersed production system had achieved exactly what Beaverbrook intended. It was nearly impossible to destroy. Even if German bombers had somehow identified and targeted every workshop, the system could adapt. New facilities could be recruited. Damaged workshops could be replaced. The network was resilient in a way that concentrated production could never be. This resilience had strategic implications that extended far beyond Spitfire production. The lessons learned in the winter of 1940-41 would influence British war production for the remainder of the conflict. Other aircraft types, tanks, vehicles, even ammunition production, would adopt similar dispersed manufacturing models. The Germans, by contrast, maintained concentrated production facilities throughout the war. When Allied bombers began striking German industry in force in 1943 and 1944, the results were devastating. German production collapsed because it was concentrated and vulnerable. Britain had learned the opposite lesson: disperse, adapt, survive. By spring 1941, the immediate crisis had passed. Fighter Command had more Spitfires than it had pilots to fly them. The threat of German invasion had receded. Britain was still in danger, still fighting for survival, but the desperate edge-of-defeat atmosphere of 1940 had eased. The dispersed production system continued operating throughout the war. Some workshops returned to civilian production as the threat diminished and new, purpose-built factories came online. Others continued producing components until 1945. The workers who had improvised Spitfire production in garages and bus depots returned to their peacetime occupations, often with new skills and a quiet pride in what they had accomplished. Lord Beaverbrook remained Minister of Aircraft Production until 1941, when he moved to other roles in Churchill's government. His abrasive personality and disregard for bureaucratic niceties made him many enemies, but his achievement was undeniable. He had taken a catastrophic industrial collapse and transformed it into a triumph of improvisation and determination. The Spitfire itself would become one of the iconic symbols of British resistance. Its elliptical wings and distinctive silhouette represented defiance, courage, and the refusal to surrender. But behind that symbol was a less glamorous but equally important story. The story of hundreds of ordinary people in workshops and garages across southern England who had built those aircraft under impossible conditions. They were furniture makers and mechanics, truck drivers and quality control inspectors, teenagers and retirees. They worked in unheated buildings through one of the coldest winters on record. They maintained precision tolerances while working by candlelight during blackouts. They transported components along blacked-out roads under threat of bombing. And they produced over 2,000 Spitfires between October 1940 and spring 1941, aircraft that helped save Britain from defeat. The final tally of the dispersed production system's achievement is staggering. From the ruins of the Southampton raid to monthly production exceeding 300 aircraft represented a 130% increase in output in just 6 months. It was accomplished without major new factories, without significant increases in raw material allocation, and without any reduction in quality standards. It was, quite simply, one of the most remarkable industrial achievements of the Second World War. The lesson was clear. Concentrated industrial might, the model that Germany and most other nations followed, was powerful but vulnerable. Dispersed civilian ingenuity, the model that Britain had been forced to adopt out of desperation, was resilient and adaptable. In the end, resilience mattered more than raw power. The Spitfires that emerged from bus depots and garages in the winter of 1940-41 did more than defend Britain's skies. They proved that a nation fighting for survival could adapt, improvise, and overcome obstacles that seemed insurmountable. They proved that ordinary people, given the tools and the motivation, could achieve extraordinary things. And they proved that sometimes, the most important victories are not won in the air or on the battlefield, but in workshops and garages, by people whose names history has largely forgotten but whose contributions made all the difference. The German bombers that destroyed the Southampton factory in September 1940 had intended to cripple Britain's fighter production. Instead, They had triggered a transformation that made that production nearly indestructible. It was a miscalculation that would cost Germany dearly in the years to come, as Spitfires, built in hundreds of small workshops across southern England, filled British skies in ever-increasing numbers. And somewhere in those skies, pilots flew aircraft assembled in bus depots by furniture makers and mechanics, never knowing the extraordinary story behind the machines that kept them alive.